So I don't really have much to cover today. So chapter 3 is just the review of what's the fundamental of how we do modeling. Okay, so it's the first part was just talking about how we can write our most probably is the linear modeling, the formula, the syntax. So I'll start with the linear modeling, followed by the polynomial, and then we talk about how. Then they also talk about what are the packages, what are the functions that we can use to compare models. So let's start with here. Need to minimize. So in the R, how they actually write the syntax is first, you will first need to import the data in as a data frame. So in their case, in this case, they are using the trees data. And then what you can do usually before modeling, the same thing that I will do is I will run the correlation package, which is CORR. And from there, I will look at the correlations. So they have three things, the three factors they are interested in, or there are only three factors in the whole data set: the girth, height, and volume. So as you can see, the girth and the volume has really relation, almost 1.0. And the volume, the height and the volume is almost like 0.6. That's also considered like moderate correlation. So if you look at the scatter plot, you can see girth and height has really like linear correlation. So we will say as the girth increases, the height seems to increase as well. Okay. How we can fit linear regressions. So in tidy modeling, it's very important that you look at the syntax that how you fit the modeling. So we can use the most basic in the base are the LM functions. So what happens here, you have two parts. You look at the left and the right. The one on the left usually refers to the response variable. In this case, we try to predict volume from if you use dot, is all the factors towards the left. So this one really depends on how you key in. So if you look at here, volume is here, the column of the volume column is on the most right. So when you use dot, you are actually referring to everything to your left. So girth and height. So they are trying to predict volume using two factors, or what usually we call the predictors, or you can think of it as in I call it the fixed effect. So you can think of it, they try to predict two things, the girth and the height. Okay, and this one is for your data, specifically telling you have to get it from the trees data set. So when you first key in this one, nothing will come out. They obviously run the function, but nothing will come out. So in order for you to get the output, you have to run the object, which is the reg_fit. The other way that I usually do is I use the summary functions to get all the coefficients as well as the R². So we will see this. So if you don't use this, if you write in the normal way, this is the usual way that I'm writing, like volume, then tilde, you have the two fixed effect, which is the followed by data trees. I rarely use the dot functions because then I wouldn't remember what's the previous fixed effect. But for some people, like really, if you really you're just interested in the coefficients and you just want to run a very quick modeling, you can use the dot to get all the fixed effects that you have in the data. So if you want to get, here they talk about how you can incorporate it with the, what is it called? This is the connector or something. So This is the characteristics of the tidyverse. I have no idea what to call this, like percentage, more than percentage thing. So I think of it more like, call it as then. So you can combine multiple functions instead of writing like one object into like one. You can combine multiple functions and just refer back to one name or one object. So if you want to write the LM functions, the best is you want to use it with the formula functions as well. This is because if you're using the dot one, the way they interpret it, they will bypass it. So how you can write is you can get first, you get the tree. You're telling them that I'm using the data. Then as then, run the formula LM. Okay, then you put in your formula, which is volume, predict using all the other factors or all the other fixed effects the data set. Then data, you can just use dot. So this one, when you do use dot, it will just refers back to the first one, the trees here. So when you run interaction effects, usually if you have two fixed effects, you will want to run the interaction effects as well. So the usual way of in my field is we will just run the multiplication sign. So girth multiplied by height. So what you will get is actually three coefficients. You will get one fixed effect for girth, another fixed effect for height, and another interaction effect for girth and height. So you should get three things. Okay, so this is the same way. This is the easier way to write, or you can just write girth plus height plus girth height. So you can write out the long way, or you can just write girth multiplied by height, and this will get you all the possible effects that you can get. If you're trying to do a polynomial, like let's say to the power of 2 or power of 3, once you look at the scatter plot, then you realize that, oh, it's actually not a linear relationship. You can try for polynomial terms as well. You can use like one thing is the identity function. So this one allows you to apply inline math to it. So you will like girth, you will up to the power of 2. So it's just like a quadratic function. So we're still predicting the volume, but now you have actually three different predictors or three different fixed effects. Girth by itself, or girth square, and height. And obviously you need to call out the functions. So then you will get the coefficients. So you will get 3 here. And what we can see, let's look at the difference between linear and polynomial. So it's good that usually you try to, as in the initial stage, you might want to try to explore the linear equations versus the polynomial equations. In the initial stage, let's say if you look at here, the intercept, if you multiply it, this is the baseline, the intercept. So assuming that the girth and the height, the interactions, I think this volume will be 69. So this is the baseline for the volume. The girth is negative, which doesn't make sense a bit. But then the height is also a negative height. But given that this girth and height means, so how we actually read these fixed effects is, as girth increases by 1 unit, your volume actually decreased by 5. And this one, as the height increases by 1 unit, your volume actually decreases by -1. Oh, now it does make sense. Sorry. So this is the baseline, because your baseline is a positive. So when you decrease by 5, it's still positive. So this one does make sense. Sorry. But for the polynomial one, you have a baseline of a -1. So as 1 unit increases in girth, you actually decrease -2.89. And so this one is a bit weird because you're not supposed to get a negative volume. If you use a polynomial, it seems like this polynomial is not really a good fit. So the other thing is you can always up to, let's say, another one, volume, if you do tilde, you're trying to predict volume. When you have a dot to the power of 2, so what this running is, they will give you the girth, the height, and also the girth and the height interactions as well. So everything, this one will be up to the power of 2. I see no questions, so I will continue. So the other one is you can remove intercepts, but we rarely remove intercepts because usually you want to know what's the baselines and what's the increase and decrease when you put in all the fixed effects. Then only you can compare the models. So in this case, sometimes if you want to remove the intercepts, what you can do is you just add a +0. Then you will get only 2 outcomes or 2 beta coefficients, which is the girth and the height. Okay, then if let's say you want to add, let's say here is what they added, a new group. So that's a new column called group A, B, C, D. So they have 4 new groups. Okay, so one thing is they're trying to emphasize is, I'm not sure how familiar you guys with the dummy coding. So in dummy coding, if you use R, they usually will, if you use the functions, right, to dummy code, they will fix it for you. But in my field, actually, what is preferred is you define the category yourself. So usually I will do the coding, dummy coding outside. So what you can do is create a column, something like this. So group B, C, and D. So how you actually read it is you will look at it. So if you this one, you will need to have something called the control group. If you do it in R, they automatically, the one with the alphabet, they'll arrange things in alphabetical order. Then the first one is always the control group. But sometimes in your analysis, you might not want to have like A as your control group, the first group, the first alphabetically ordered group as your control group. So you might want to create a new columns yourself. So when you dummy code, how you do it is, let's say I want to control, you have one column, you control group B versus your control group, in this case is group A. So what you do is all the rows of data from group B, you code it as 1, and the rest will be 0. So if you have group C, you want to control C versus A, what you have is all the C groups here, you will have 1, then the rest will be 0. Then for D is here, you will have all D 1, then the rest A, B, C will be 0. Then you run this group B, group C, group D. So how they, I find interesting is how they do it here using the model metrics, because I've never used this before. So they do it in the model metrics as in, it seems that when you use it, I try it out, and when you use these model metrics, they automatically create this group for you instead of you dummy code it yourself. So this is convenient if you don't really care about which group you're comparing with. But if you, let's say you're trying to compare, let's say in the clinical studies, you're trying to compare group, let's say group B plus C versus the control group, like means treatment without or without treatment, you might want to learn how to do this dummy coding. And it's actually quite easy, like you can use with the, try to recode it from 1 to versus 0. Then the polynomials, you can do up to polynomial to the power of 2, or you can do a cubic functions, so up to the power of 3. And when you do dot 3, it means that they will get everything up. So everything power 3, the polynomial. So in this case, you have girth. Remember now you have additional 1 group. group B, C, D. So girth, height, group B, group C. The convenience of using one dot is they will run everything for you. So group B, group C, group D, the fixed effect. You have girth versus the height, girth versus group B, girth versus group C, height versus group D. So you get the sense of all the possible combinations. You will get the coefficients for all the possible combinations that you can get from that data set, just to predict one volume. Then from here, you can look at which is the most highest confidence, and you look at the p-values. So just recaps the formula. How you actually write the formulas defines your model. So they will say here the formula defines the column. So what you put inside the model is usually by columns. And before that, usually the best practice is here is that you want to ensure your columns is in appropriate format. This applies for, I don't think this applies so much for LM, but if you're doing a mixed modeling, you want to make sure the columns, the data actually is in, let's say, in numeric or in categorical, or you have not dummy coded it. So the way that you put it, writing out your formula syntax, that's really important, and make sure you know that the fixed effects, whether it's a numerical column or whether it's a categorical data. So it's very important you know that. Then moving on to the next part. So when you inspect and develop models, so let's say we have a model that we want to do. Before we run model, like supposedly, we're supposed to run some assumption checks, right? For linear regressions, that we also need to check certain assumptions. Usually we try to skip that, but we really need to do this. So how you can do is you can use the plot functions and with the LM to get various diagnostic plots. So the four main one, they have these residuals versus fit, the normal versus QQ plot, and the scale locations or the residual versus leverage. I do this, but I don't use this model as much. What the other thing that I do is for one. So one thing that I use to run all these assumption checks, because I don't really remember how to read the main diagnostic plots all the time. So usually I use this performance package. And when you run this, when you install this performance package, you can use something, not this compare one, but you can check model. So there's a functions inside this package is called the check model, where you can check for linearity, you can check for HOV, the homogeneity of variance, the normality of residuals. So then also like what are the outliers. Okay, so this one is really convenient for me because usually they will tell me like how I can read the diagnostic plot. So for example, like for this HOV, they will tell you the reference line should be flat and horizontal. So when you look at it, if it's not flat, then you kind of like know that, okay, maybe I need to look back to my data sets. The same for this one. This is the fitted value versus the residuals, and this one looks at the linearity. Usually your reference lines are about flat or horizontal. Here you can see it's a bit skewed. Then back to here. So if you do not want, you want to go with the base R, that the way to do it is you can use this plot function. So first, just now we run it, and then we can do these plot functions. So you run the first two. So this one is looking at residual and fitted values. So this is looking at linearity. You want it to be linear. As you can see, they are not linear. There's some kind of violation there. Then this is a normal QQ plot. You want it to be almost near to the line. We have some outliers, but I don't think it's like seriously violated. Okay, so the first one, this one is actually violating the linearity assumptions. And linearity assumptions, just to clarify with you guys, means that it's a linear relationship between the response variable, in this case, the volume, and the predictors, the rest of the factors. Okay, you can also look at, they also introduced some called this library called GG45, which I haven't used. But there it seems that you can use this auto plot and you will generate the same graph. So I think it's doing the same thing as the performance package. Okay, this is the part that I was talking about. Okay, just now when you run the models, it does not get you the coefficients. It does not tell you how well your model is actually performing. So what you need to do to get the coefficient and also to get the model fitness, everything, you want to run a summary. You first store inside an object, then after that you get a summary of the model. So then usually they will tell you what is the model is in the first line, the core. So in this case, you are predicting volume from the rest of the factors. You can see the intercept is a negative intercept and your curve is 4. So for every 1 unit increase in the curve, your volume increases by 4. And then for every 1 unit increase in height, your volume increased by 0.34. And interesting, we usually need this to determine whether your fixed effect is significant or not significant. You can see the p-value is less than 0.05, actually less than 0.001. So 0.001, so that's why it's 3 asterisk, less than, and this one is just less than 0.05. So these two are actually significant predictors for volume, but the intercept is negative. Other than that, you can the R-square or the adjusted R-squares. And this model, what it actually tells you about the R-square is this, with just these two predictors, it seems that they are very good predictors. You can actually predict it quite well. You can predict the volume using these two predictors. Then this will tell you the F statistics. If you run ANOVA, the F statistics on 2 and 28-degree freedom. So this model is also significant, means you can consider using this model. But this is the output from the base R. You just use summary. It's good enough for you to read. What if you just want a tidy version? So with this time, we have to use something called the Broom package. So when you just run this formula, tidy, they will list it out more like in the data frame structures. And the amazing part, they are in 2 or 3 decimal points. So you don't have to read like, it'll make your reading easier of the statistics. So then you can look at, it will be the same output, it's just that you'll be in a neater manner, it's more neat, and you can look at the p-value and the beta estimates. Okay. Then obviously you can use the standard connector, the model fit. Then you glance and glimpse. This one will get you the model fitness. So back to this one. Actually, sorry. So what I actually use is also one thing using the performance package. assess how the model quality is, you can also use, first you run, then you can do the model performance. This will get you all the or adjusted R-square or AIC or BIC's values. So that's also one thing to consider. So the same thing is if you just run regression fit, glance, then glimpse, this will get you the likelihood, AIC, BIC, and the degree of freedoms with the sigma. And obviously R-squares and adjusted R-squares as well. And this is the F statistics with the p-value. So everything is just the same, but this one is just for the model fitness. So let's say you run multiple models and you want to know, which is the best model out of this all? Should I use the linear one? Should I use the polynomial one? Or the one with one missing effect? So you run all the models, then you can compare the models. So first you list out one by one which model that you are using. So here they use regular, just means everything. Okay, I don't remember the inter one, but the poly one is the square one. And this one is without the height, and this one is without the intercept. So you label it. Then you use the function called map data frame. You take the glance, this one will get you all these things, everything here. So it's similar to this function. And then the ID is just based on here, the ID. Okay, and then what they want is you just want the adjusted R-square, the model. So then obviously I arrange it in highest to lowest. So it seems that the best model so far is the polynomial one with the inter one. What is the inter one? Let me check. The one with the interaction. Back to here. So sorry. So this is the regular and this one is with the interaction. Between here, polynomial and the interaction, they about the same. I would say they both about the same, the adjusted R-square. So I think they both perform. So polynomial seems to be the best, but you do want to consider the parsimonious model. So whichever with the less predictors but perform the best will be the best. But they are not like significantly different. But there's a way to check which model is the best using what I will talk about later on. So you can also, in the modelings, let's say you want to run a different models for different groups. So do is using this group nest function, and you group them based on A, B, C, D. Okay, here looks very complicated, but actually if you just read line by line very slowly. So the formula is, let's say I want to run, you first fit the model, the volume, everything, and then you want to convert it into the tidy format. Okay, that's why you put fit this thing into a tidy format. Then I just want to get the glance, means you just want to get all the performance of the model, all the matrices that you can measure the model. And then you use the augmented one. This will get you the additional matrices. So like the Cook distance bounds. Then this one, you run it as in, then we will have and create another functions is using the data. You select the group and then you need to unnest it. So do is you first run regular fits this one, and then once you run it, you make sure that you unnest it. So just to do unnest it, create a functions here. So what you get is you'll get based on A, B, C, D. You have each of these, you will have this model like curve height, intersect curve height, intersect curve height by groups. And then if you just use the glance one, you see here is the tidy one. So you will just get this one. Then the glance one, you will get the R square, adjusted R square, sigma, statistics, and logic. So I didn't really go through in details, but because you really need to spend time and look at this. So if you have time and if you have not read this chapter, please do help yourself to read it. Because I think this is very useful way of like running all the analysis. You just need to write one functions and you can run all the analysis. The same modeling, but just for different groups. So it's a modeling based by the group. Then more on the base R and the stats. So I use more of the tidy words, so I'm not really familiar with base, but I think here they have base has a few functions that are really important. So this one is how we want to know which model are better. So sometimes you need to make the decisions like whether should I use just the regular linear modeling or should I just use the one with the interactions. So we build from the simplest model to the most complicated model, then we compare each of the complicated model with the simple model to see the model that best predict the volume. So what we can do is we run an ANOVA, so you're just checking the two models. So the regular one versus the polynomial one. So they will compare model. Obviously, they will list out the models for you, so you can go through the models. And what you can see is, the second model is significant. So it seems that the polynomial model seems to provide more power or more. The R square explains the volume better. So if you just square the curve out, plus the curve plus the height, this additional one fixed effect squared seems to explain the volume better. Okay, here is, I don't think, so ANOVA, I'm not sure how it, so we're just comparing two models. You can do the same just now, as I said, in the performance package. You can use the check model as well. That one will get you more of the statistics. For example, AIC, BIC, those kind of likelihood model. So if that's important for you, you can check out that package as well. This is about histogram. So this is just a codes to write the histograms. As you can see, this one is more normally distributed. So they have this histogram of X and histogram of X. Then when they combine two, it seems that this becomes more normally distributed. I'm not sure what this person is trying to do when they write this code, because I couldn't make sense of what is important here. Then I'm not sure what you guys think about that. Then there's a lot of other functions. They talk about all these other functions that you guys can look. But I think what important is we should focus on the next part, which is why do we want to use the tidy principles and tidy models? Because if base R like base R, the LM functions allow us to do all these things, like why do we need to learn tidy models? So before we know why we need to learn tidy models, let's look at what are the guiding principles for tidy words and tidy model. So tidy words is just human-centered. So from my personal experience, when I first learned base R, it looks really complicated because it's very difficult to read the codes because they have all these dots and they don't explain it and they put it in a single line. But for tidyverse, it's really human-centered. So one line always refers to one function. That's why it makes the reading much easier. So tidyverse is human-centered. It can support activities. The functions are more sensible. And for example, they say there's no, in the case of usual default, in tidyverse, they always have this default choice. So if you don't key in, they will go with the default choice. In R, you always have to key in the path so that they know where to run it. So we haven't looked at the recipes and the path state, but this allows the data frame to be used when you are in the modeling processes. It might be more complicated because instead of just running one L and Y, then you need to create a recipes. But the way that I think it, if you use tidy models, you can repeat the same thing. So you just need to write the syntax once. And if you use it the same or similar situation or similar data set, you can adapt it very fast. You can just adapt the model. Then the rest of the steps, like for example, in the recipes, those are the things that you just need to change the model and the steps, the rest on how to generate the summary, the coefficients, and model fitness. Those are the fixed things. So it makes coding less time consuming by the next time you do need to run the modeling. It's very consistent because tidyverse, tiny models, they made of multiple packages. So when you learn just about tidyverse or tidy modeling, things that you learn in one tidyverse applies in tidy models as well. So it's an object-oriented programming, which is very easy, and then you can combine the functions. Okay, and I think this one talks about predict. In the book, they talk about how predict in different packages actually are computed differently. So if everyone is just using like tidy models, then we might have a more consistent output. Everyone would not get a very different output. Because predict is one of the things important in modeling. You want to see how these models better predict the volume. So even though you run the modeling, you want to predict something out. And the tidy version is really nice because it gives your output in the data frame rounded off to like 2 significant decimal point. Okay, and it's very composable because instead of like you need to think the workflow in one go, in tidy models or tidyverse, there are separate packages. So this is a huge, like tidy model is a huge umbrella package. Then you have all these like smaller separate packages that to perform each of the tasks. So this allows you to slow down and start thinking you want to build models. Okay, and it's inclusive because everyone seems to be using it. So that's the end. Do you guys have any questions? I know I rush it out a bit. If you have any questions, please do let me know.
This was great. Thank you. I have a few notes, I guess, like points of reference. The percent greater than percent operator, I think it's called the pipe operator.
Oh, I always call it S then because that's how I read the code. I read line 1, then S then move on, or I just call it next.
Oh, cool. Yeah, it's from, I think I read it in the R4DS book, R4 data set.
Is it from the, I remember, what is it called? It's from the Margaret
yeah,
package,
it's
right?
from the migrator package, and starting from R version 4.0, I think it also has the base R pipe operator, which is like the vertical line, and then like greater than operator, which
Oh.
then you don't have to load the Magritte package. But then again, it doesn't. It's a more basic sort of pipe. It doesn't offer, for example, the behavior where you can use the dot. What the thing you showed, where you can use the dot to say, the thing I passed on into this pipe, you put a dot to show it, so it doesn't
everything
use,
to the left. Yeah, it doesn't do.
yeah, it's just passes normally, and you can't use it again, so to say. Yeah, I started using the base pipe operator like as a default in my RStudio profile. So just so I think it's easier to say pipe or pipe operator than to say percent greater than or percent.
Yeah, I don't usually do presentations, so that's fine.
Yeah, me neither, you know.
Yeah. But yeah, I was also looking at because when I was preparing for this presentation, I also saw because currently there's a new the arrow sign. That one, what's the one? The one that they try to replace the pipe with. Not the
arrow, like an assignment arrow, you mean?
Yeah, the assignment arrow. Not with the pipe, but there's the assignment arrow. I was like reading on the discussion. But let me go check once again, then I'll let you guys know next week.
All right. Second thing, I wanted to thank you because you showed me two things that I wasn't familiar with, which were the first thing is the formula function, which I never used, and the way you showed it with using it with the Magritte pipe and the dot sort of operator, and I'm not sure how to call the dot where you say not like I'm not sure how to say it, like it was in chapter 3.1 where like the dot represents two different things. Once it represents all other predictors, and once it represents the data, the trees data.
Yeah, back to the whatever you have referred earlier.
Yeah, so using the formula function is a good solution for this, and I weren't aware of this option, so thank you. And also the performance package, I wasn't aware of it, and it seems like a really good package, and also the plots look really like well defaulted, like they look good. So so thank you for that. And one last note is I've noticed somewhere in the code there was the map_DFR.
The map data frame.
Yeah, which I think is superseded by now. Like per the package, like the map function comes from, just had like a few months ago. Like 4 months ago, it had its like 1.0 release, and this function was superseded. So it's not going anywhere, but maybe we should consider changing the code to have something like which is more up to date. Maybe I think I look into, maybe I'll open a PR for this.
Like, do you have the links to like
sure,
because I haven't been keeping track with the new releases, like the codes.
Yeah, that's because, you know, I'm really for the tidyverse. That's really what actually got me into R, like the way you presented it, like with all of its characteristics or like the pillars of the tidyverse approach or design philosophy. This is really what got me into R. I was like an Excel user, and I wanted to use something more more advanced, and base R always seemed like it doesn't really help me. It's like, or it does, but I can learn every other language. Like I can learn Python, or I can learn, you know, C or whatever. It's like it doesn't matter, but it doesn't matter. But then when I got to know the tidyverse, it looked like a really good like toolbox. So I started following like everything that comes from RStudio or Posit. So this is the link to the per 1.0 release, like the blog post about the release, and they briefly talk about the how map data frame is superseded.
Oh, okay. I'll read. Thank you.
Yeah, of course. And finally, I had like a question, I guess, or like a point of discussion where I got to know the many models framework that you presented, like how to work simultaneously with, like, to inspect many models and to use them. Also, the R for Data Science book exhibits this approach, and it looks really sensible and smart. But then again, every time I need to do like some sort of regression or statistical analysis, like in the moment of truth, I'm like, I just do, you know, LM like the normal code, you know. I don't like go the whole way. So I wanted to ask how it's like for you or for Federica, if you guys are doing it any differently.
Oh, I'm not sure because I'm in research area and not really in data science. So how we were like taught to do modeling is need to have base your modeling based on the literature. So we read tons of research and see what are the modelings that people have looked. But also the most important part is the first initial data explorations, where we look into the correlations. So from the correlations, you kind of know which will be your fixed effect and which one will kind of be important, what we call as important predictors. So what we've been taught is we start with the most simplest model. So you're trying to put like maybe 2 or 3 predictors, the common one. Then if you check the R square, okay, it's not really working out. The R square is like really low. Then you try to include more predictors. But as like they always want, what we want is always the simplest model. So every time we add one new model, we will compare like model 1 with model 2. Then if like model 2 is better, we abandon model 1. Then we come up with another new model, model 3. Then we compare model 3 with model 2.
Yeah, so you do it like interactively, like you check it every time.
The shortcut is always we come up with multiple models, like model 1 to model 10 simultaneously. We write everything. Then I just use the check model in the performance package. If you run compare model 1 to model 10, then you tell me which is the best model. So that's the shortcut to it.
No, but like it sounds like it might be a shortcut from like a theoretical perspective, but from like I don't know, like from a data science perspective, it seems like a good approach. Like you can do all of the steps just like in a more code efficient way, I guess.
Yeah, that's like really, because if you just want to run one model and compare with the previous model, it's really time consuming. So what I use, like I think of all the possible combinations that I can get. Then I write out all the modeling steps. Then I just compare the performance of the model simultaneously. Yeah.
Okay, great. Thank you so much. It's really interesting, and also it's really nice, like the whole notes, like for the presentations, like it's like another resource, like additional to the book. So it's really nice and enriching. So thank you.
Thank you so much for the kind. Federica, do you have any other things? Do we have anyone else presenting next week?
Yeah, but we'll see if someone like to do the next chapter, or we'll catch up on Slack in that case. And yeah, I think it's most probably. I don't know if maybe Matan. Would you like to do that?
Yeah.
Yeah, that's great.
Yeah, I think. Wait a minute. Just let me look at my schedule to look at next week. Yeah, sure. So, do you want me to present next week instead of the next 2 weeks?
It's up to you, really. You decide what you like to do.
Yeah, that's fine. I can do that.
Yeah, that's okay.
Okay.
You can even do the following week again. For us, it's fine. If you want to do 2 weeks, it's absolutely
2 weeks
fine.
in a row. Let me see.
No, I mean, if you want to do next week, and then again you want to present the other chapter the following week, for us it's fine. I think it's absolutely good. It's up to you.
I think like the way it is right now, it's best for me. Like that I would present the next week, and the week after that, we'll
Someone
see.
else does.
Like I just
Okay.
my schedule, something might have popped up. So right now I don't want to take the responsibility.
That's okay. That's great. That's absolutely great. That's okay.
All
Yeah.
right.
Thank
Yeah.
you.
Okay, bye. Thanks.
Thank you very much.
I'll
Have
see
a
you
good
guys
day.
next week.
See you.
Bye.